Hello and welcome to Team Short Circuit's final presentation. I'm Jeff Bosdet and my partner is Isabella Ip. Together we made a course on basic electronics and the Arduino microcontroller. This course does have a bit of a programming prerequisite. Students need to be able to understand variables, conditionals, loops, functions, and some basic object-oriented programming, but they do not need to know anything about electronics. It'll take them through voltage, current, resistors, pulse width modulation, all the way through to controlling LCD screens and motor driver chips. And the final project, they built a robot that is eventually capable of Bluetooth control from their computer. So pretty awesome. The motivation for this project is that I'm not just the developer of it, I'm also the client. I teach high school robotics, and this year I taught an early version of the course, but I had a bit of a problem. Some of my students were brilliant, future computer scientists, whatever. Some of my students just didn't want to take art. So I had these two groups of varying motivations, and by the end of my course, I had my top students 2 months ahead doing amazing stuff, and my bottom students 2 months behind. So having that 2-month gap between them really made things difficult. I ended up having to teach the same stuff 4 times, and so this course will allow my students to be more self-paced. I don't have to do the same lecture over and over, and it'll give me more time to help my students, and hopefully they'll learn more. It should also give my top students more flexibility in some of their projects. I'm excited about it. It's not really designed to be a massively online course, as I will be in the classroom 3 times a week with my students, helping them through it. It could easily be adapted to it, and there does appear to be a demand. Our peer feedback has shown a lot of interest, and research we did doing the various assignments showed that there are tens, if not hundreds of thousands of people interested in such a course, and there's not that many good courses. This course, in many respects, is better than any other out there. So if I can find a source of cheap hosting, I'd be interested in making it available to the world. I'd like to go over a few of the strengths of the course. First strength I'd like to make note of is there's a lot of content. If you check it out, there are 13 units spread amongst 3 sections. And if we check the servo unit, for example, notice there are a lot of parts that make up that unit. In every instructional part, there's a video which is intended for the first time a student goes through it. If they want to learn the concept in detail, it goes into this particular case, servo constructor and functions in detail. If they need a thorough review, the video is again a great idea. If they just need to know a little bit, there are written notes associated with all the instructional lessons that'll help them get what they need. They'll also need to have this all down and need to be reviewing because there's a lot of conventional assessment. Notice in the servo unit there are 3 sections, 3 quizzes associated with it. And they're filled with a variety of multiple choice questions. In this case, there's a bunch of enter the line of code. In other sections, there's checkboxes and a few other question types. So there's a significant amount of conventional assessment in these units. Another area of strength for this course is all the projects. To make it this course, I designed 10 original projects and an original robot as well. It comes in various stages. Let's take a look at a few of them. This is what I called the versatile light. You can change the colors and adjust the brightness with the potentiometer. This is designed to practice the use of the RGB LED, analog read with the potentiometer, and analog write in controlling the brightness of all those things. This is a circuit I came up with called the light controlled servo. Kind of like it because it's feels like magic. You don't touch it, and there it goes. So you get a voltage divider with your photoresistor, and based on the analog read of that, determines what signal it sends to the servo. This is the reaction speed tester. You press the button when the light comes on. It comes on about every 5 seconds, but it's random in when it comes on. It keeps track of how long it takes you to hit the button after the light comes on, and also how many missed button presses. If you press the button when you're not supposed to, it keeps track of that as well. Here's the voltmeter. It's designed to get the students to practice working with the LCD display, and also to mess around with using it with sensors. This is the joystick controlled motor I designed. It takes the difference from the center position. It has a little dead zone, and when you get beyond it, you can slowly increase power in one direction or the other. This is the final robot project. It's built and programmed in stages. Initially, the students just program a bunch of functions for making go forward, left, right, back, and stop. Right after that, they figured out how to use the ultrasonic sensor on the front, send out a pulse, and figure out how long it takes for the pulse to get back. And doing a little bit of math, they figure out how far something is in front of it. They give it wall avoiding ability. And then the final stage for the robot is Bluetooth control from a computer, and also the robot sends back the distance to the object in front of it. The course feature I'm most proud of, and one that I haven't seen in any other courses, are my Arduino simulations. There are 13 of them sprinkled throughout the course, and let's take a quick look at one. Students only get to see the Eno file, which is the standard Arduino file type. They're guided through to finding the solution. And this is the way I managed to simulate it. I just have piles and piles of functions that mimic the various Arduino commands. And then there's a hidden main function that imports their code and then tests it against a variety of test cases, giving constructive feedback if they're messing something up, which will hopefully guide them to getting the right solution. I hope you enjoyed learning about some of the highlights of this course, half as much as my children enjoyed following my robot around. If you are a future Georgia Tech student interested in building upon this, you're welcome to do so. Some suggestions would be adding I2C sections or software serials so you can connect to more interesting components, adding Wi-Fi to the robot, or using a Raspberry Pi with an Arduino slave to add analog read and pulse width modulation support for your Raspberry Pi. Thanks for listening.